Good day guys, this is your tutor engineer. Welcome to another video on Euclidean geometry. I've already done a couple of videos, so you can go back to those videos and check them out. Today we're doing this question 10.2. So just before I start, remember to subscribe and like this video. Okay, so let's just get straight into it. So it says here 10.2 in the diagram, M is the center of the cycle. So remember, if they say M is the center of the cycle, there is M, right? So you can see you're going to apply the angle at the center is twice the angle at the circumference. So if you have 38 times 2, so that means typically you'll be getting M is 78 by using that theorem. Okay, so we can go on, right? Then they say A, B, C, and K and T lie on the cycle. AT is produced to CK and meet at N, and NA is equal to NC. So okay, all of this NC and NK are equal. So you know what that means? It means this angle there is equal to that angle over there. And then you can also see that angle C and B are equal by angle at the that are sharing the same arc, which is AK, or angles on the same segment. So that means this is 38, this will also be 38. So that is it for now. We've simplified the drawing as far as we can. So now let's hear the question, right? So the question is asking us to calculate KMA. So let's see KMA. We've already calculated KMA, that is the angle at the center. So we can just say the reason why did you say it's 76. So basically KMA is equal to 2 times 38 degrees. The reason is angle at the center is equal to 2 times angle at circumference. So that's just the reason. So that means that's how we got 76 degrees for KMA. And then that's it. That's the first question, right? So now let's go for question number 2. It says you must find angle T2. Let's have a look. Oh, here is angle T2. You can tell it's also equal to angle B, or it's equal to angle C, if you realize that T2 is the exterior angle of a cyclic quadrilateral. So we can say angle T2 is equal to angle B, which is equal to 38 degrees. The reason is exterior angle of cyclic quad, right? So I'm running out of space, so I'm just going to write it out like that. So exterior angle of a cyclic quad. So now let's go for question 3. We're looking for angle C. So angle C, you've already said is 38. Remember the reason? So we said angle C is equal to angle B because those are angles that on the same segment, right? Which is segment KA. So again, just write out here to say the reason is angle on same segment. And that is it. So these questions are just basic questions. The reason we are so quick, remember, it's because we simplified the drawing before we started out with the questions. So that's why it's so simple. So remember to do that. I find that method very easy to execute. So now let's look at K4. Let's look for angle K4. K, so there is K4 over here. Okay, so we also realize that K4 is the exterior angle. It's equal to angle A. It's not equal to angle B according to this, right? So remember, the exterior angle must be the extension of CKN. So that would be K4. So we know that K4 is equal to angle A, which is CAN. Let me just write it out like that, CAN. The reason you're going to say exterior angle of cyclic quad is equal to interior opposite angle. Interior opposite angle, which is angle A or angle CAN. Okay, remember we said CAN is 38 degrees. The reason for that was we're given that AN is equal to NC, right? So if you remember, so we know that but CAN is equal to angle C is equal to 38 degrees. Why? Because those are opposite angles of two opposite equal sides, right? Because NA is equal to NC, you can just maybe write comma and say NA is equal to NC. So since we know that CAN is 38, K4 is equal to CAN, that means also K is equal to 38 degrees, angle K4. So that was question 4. Let's look for the next question. The next question is we need to show that NK is equal to NT, right? So you can tell here, let me just change the color from here. Let me use a black color. NK, there is NK and there is NT. So if you can prove that K4 is equal to T2, then we would conclude that NK is equal to NT. You realize that we found that K4, we've already proven that it's 38 degrees. And T2, likewise, we found that it's 38 degrees. So we can just conclude this here to say, since angle K4 is equal to, and both and T2, they are both equal to 38 degrees, right? So this we've already proven in question 2 and question 4, right? It's proven in question 2 and 4 that they are equal to 38. Therefore, we can conclude using the converse of the opposite angles is equal to 2 opposite angles of two opposite equal sides are equal. So using the converse, therefore, you can conclude that NK is equal to NT, right? So that would be the converse of opposite angles of two opposite equal sides. So that is our proof. So now let's do the final question, final for today. 10.2.3, prove that AMKN is a cyclic quadrilateral. So that would be AMKN. So that's AMKN. Okay. So we know about angle M, it's 76. If you can prove that angle M plus angle N, if you add them, you get 180 degrees, then it will be our proof. But we don't know what is angle N. So remember, now we need to prove that angle N plus angle KMA. If you can prove that they are equal to 180 degrees, if you sum them up, then it will be the proof that AMKN is a cyclic quadrilateral. Okay, we know about KMA. We've proven it under question 1. You remember? Do you recall? We found that it's 76 degrees. Okay, now let's calculate angle N. We don't have angle N. We can use the triangle NKT. You can just say in triangle NKT, angle N plus K4 plus T2 is equal to 180 degrees. Why? Because those are sum of the angles of interior of the triangle, right? Sum of interior angles of a triangle. So that means angle N is equal to 180. Angle K4 is 38. So if you take it over to the side, it's going to be negative 38 minus 38. What would this give us? So now we're remaining with 180 minus 38. We have to use a calculator just to be sure. Minus 38, so that's 104, right? Angle N is equal to 104. So now let's see, since angle N is 104, if you add 104 plus KMA, which is 76, does it give us 180? Absolutely, it gives us 180 degrees, right? Therefore, you conclude, therefore, AMKN is a cyclic quad, right? It's a cyclic quad. What's your reason? That's the converse of opposite angles of cyclic quad are equal to 180 degrees. And that's the end. That's the end of today's lesson. If you like the lesson, please hit a like button and subscribe. Cheers. We'll be coming up with more videos. Thank you. Bye.